my dear young friends, beloved students, welcome back to C-Level Physics. My name is Srinivas, known to be BS Rao. You are watching C-Level Physics YouTube channel meant for CBSE, ICSE, IGCSE, NEET, JEE Main and Advanced aspirants. Most of you watching my videos without subscribing, sharing, commenting, not even liking. A small like boosts up and encourages myself to make more and more videos. So kindly subscribe my channel. Please don't forget commenting, liking and sharing. So let's move on to topic. Today's topic is oblique projectile. What is meant by oblique projectile? In fact, it is very crucial as far as advanced point of view is concerned. Apart from it is most important in respect of state boards, exams also, right? Now let us see what is meant by oblique projectile. Before that, what is meant by projectile? Projectile in the sense, body should be acted upon by some constant force, right? In that situation, that body is to be projected with some initial velocity such that that velocity making an angle theta with force like that. See, this is what velocity of projection. See, this body is projected with some initial velocity such that making an angle, some angle with constant force acting on that body. This is what constant force acting on the body. Usually that is gravitational force. What is that? Gravitational force. It is constant at a given place, right? See, this is what body of mass m, which is acted upon by a constant gravitational force, right? Downwards, for example. Now that body is projected with some initial velocity such that making an angle theta dash, right? Here what is theta dash? Theta dash not equal to 0, not equal to 180. That is 0 less than theta dash less than 180. Then it is nothing but projectile. Am I right? Yes. Right? When we say that body is projectile means that is to be projected with some initial velocity such that that velocity making an angle which lies between 0 and 180. Must not be 0, must not be 180, but lies between 0 and 180 with the constant force which is acting on that body. Then that body is known as projectile and its motion is known as projectile motion. You know very well. But here what is the case? Oblique projectile. When do we say that projectile becomes oblique projectile? Means here the initial velocity should make some angle with horizontal. See, this is what horizontal. What is that angle here? Theta. That theta not equal to 0, not equal to 90, but lies between 0 and 90. See, if that initial velocity means velocity projection makes some angle with horizontal or x-axis such that the theta lies between 0 and 90. Theta, here it is theta dash, here theta dash, but here theta not equal to 0, not equal to 90, but lies between 0 and 90, 0 less than theta less than 90. Then it is known as oblique projectile. Oblique projectile. Am I right? Here, velocity of projection making some angle with the horizontal. See here, velocity of projection u making some angle with the horizontal. See, this is what horizontal, right? This can be resolved into two components. One is along the y-axis. See, this is what y-axis. This is what x-axis. This is what y-axis, right? So along x, what is the component? U, x. X component of velocity of projection. That is along x-axis. Along y-axis, this is what u, y. Y component along y-axis, right? Now I'm closing this side like that. See, if it is uy, this one also uy, right? So along hypotenuse u, along this adjacent side dx, along opposite side uy. Now we can say that cos theta equal to adjacent side by hypotenuse ux by u. So ux equal to u cos theta. This is what horizontal component of initial velocity ux u cos theta. Along vertical, what is the component to get uy? Take sin theta. Why? Because this is the opposite side with respect to theta. So sin theta equal to opposite side by hypotenuse, that is uy by u. So uy equal to u sin theta, right? So here velocity of projection can be resolved into two components. One is along horizontal, that is along x-axis. Another one is along vertical, that is along y-axis. So ux, uy. U means initial velocity. Suffix x means along horizontal. Here initial velocity along vertical, along y-axis. So ux u cos theta, uy u sin theta. So here this velocity can be resolved into two components, right? So what is that component? This is what along y-axis. Say this is y-axis. So along y-axis uy. What is uy? U sin. Along horizontal, that is ux. That is what u cos theta. So this is what u sin theta. U sin theta, right? So u sin theta, u cos theta. So this velocity can be resolved into two components. One is u cos theta along horizontal, another one is u sin theta along vertical, right? Now here, what about acceleration due to gravity? What is the direction of acceleration due to gravity? The direction of gravitational force always, alright? What is the direction of gravitational force? Means every body is pulled by earth towards its center. So this body also pulled by earth towards its center. So this is the direction of gravity or gravitational force. So acceleration due to gravity also acts in the same direction, that is downwards. So your g downwards along horizontal means along x-axis. What is the component here? Means here angle theta 90 degrees. See, this is what g acting downwards. So along horizontal, with respect to horizontal, what is the angle made by g with the horizontal or x-axis is 90 degrees. 90 degrees. Now if I close this side, we get right angle triangle like that. Now what is the component of g along x? That is ax equal to g cos 90. G cos 90. That is cos 90 0. See, g acting vertically downwards. So it finds no component along perpendicular direction. So you know very well, any vector doesn't find any component perpendicular to itself. So as g is downwards, that is negative y-axis. Along negative y-axis, what is the component of g along x or along negative x? 0. Why? Because this is what direction of 90 degrees. So what is the component of g along this way? That is g cos 90, 0. So ax equal to 0. So along horizontal, the particle or body, projected body, finds no component for g. Okay, now this is what g, in fact g. So as g is downwards, acceleration along y-axis means minus g. Why? Because body is moving above the level of projection here, right? So as g is acting vertically downwards, g becomes negative as per sign convention. So ax equal to 0, ay equal to minus g. What is the acceleration of this particle along y-axis means g, but negative sign as per sign convention, minus g. Why? Because g always downwards towards negative y-axis, minus g. So ax 0, ay minus g. Am I right? Okay. Now see here, body is projected like that, right? As that making an angle theta with horizontal. Now along horizontal, otherwise along x-axis, what is the component ux? That is u cos theta. Along y-axis, finds component along y-axis, it finds uy that equal to u sin theta. But g is downwards. G is downwards here. What is the direction of g here? Vertically downwards. See, g is downwards. G is downwards. Right? Now see, there is no effect of g along horizontal. There is no effect of g along horizontal. Why? Because along horizontal, g has no component. So, as there is no acceleration along horizontal, this component remains constant throughout its path. Alright? Now coming to vertical component, ui is opposite to g. ui is opposite to g. Therefore, g affects vertical component. Why? Because here acceleration and speed are opposite to each other. What is the difference? If speed and acceleration are opposite to each other, that is the indication of retardation. So because of g, here vertical component gradually decreases with the time. So therefore vertical motion is under retardation, but horizontal motion is uniform. Why? Because there is no component of g along horizontal. So u cos theta is constant. Let us see equation of motion along x and along y. Along x v equal to u plus a. I want to know velocity after t time along y-axis, along x-axis first of all. That is vx equal to ux plus ax into t. Right? That is vx equal to ux means what? U cos theta. U cos theta. Plus what is ax? Ax means 0. There is no acceleration along horizontal. Why? Because there is no force along horizontal. So therefore acceleration along x is 0 into time. That is, this term is 0. You left with vx equal to u cos theta. U cos theta. That is what? ux only. Ux. vx becomes ux only. That is initial velocity along horizontal. So after t times also after t seconds also, horizontal velocity remains constant, which is equal to horizontal velocity at the time of projection, that is vx. So vx becomes ux, u cos theta. Right? As there is no acceleration, this is what? Uniform motion. This represents uniform motion. Right? Now coming to vertical motion. See, vertical velocity. Take the same equation for vertical motion also. So along y, take again same equation, that is v equal to u plus a. vy equal to ui plus ay into t. Right? That is, what is uy only. Ay means minus g, ay minus g into t. That is, uy means what? U sin theta. See here, it's what? Sin theta. So u sin theta. Right? Uy means vertical initial velocity. Ux means horizontal initial velocity. So u sin theta minus gt. So vy equal to u sin theta minus g. Right? Here, in this expression, we have negative sign for the second term, minus gt. As time goes on, what happens? T increases, the product gt also increases, and may becomes equal to u sin theta also at some instant. Then vy becomes 0. Am I right? So I am rubbing off here. Okay. Right? I am writing somewhere here vy. What is vy? Vy equal to u sin theta minus gt. Vy equal to u sin theta minus gt. As time goes on, what happens? T increases, product gt also increases, then this term increases with the time. So it may becomes equal to u sin theta also at some instant. Then vy becomes 0. So here with this negative sign, we came to know that this is what valid for body projected vertically upwards, in fact. Right? which is under retardation initially, am I right? Up to reaching highest point, your vertical motion is under uniformly retarded motion. Why? Because g is constant but with negative sign, therefore it is resembles with the case of body projected vertical upwards, in which body is under retardation until it reaches highest point. Am I right? So, right. If gt becomes equal to u sin theta, what happens? If gt becomes equal to u sin theta, what happens? Vy becomes 0. Implies Vy becomes 0. Vy becomes 0, right? If gt becomes equal to u sin theta, right? What happens? Implies Vy equal to 0. Vy equal to 0 means it reaches highest point along y-axis. Am I right? If gt becomes equal to u sin theta, Vy becomes 0. Vertical velocity is 0 at some instant. At what instant means? Make it subjective. That is t equal to u sin theta by g. U sin theta by g. In fact, this is what time of ascent. Time of ascent. When a body is projected vertical upwards, the time in which it reaches highest point just before its velocity becomes 0 is known as time of ascent. In fact, so this is what expression for time of ascent. So that is the time in which its vertical velocity is 0. Right? If gt is greater than u sin theta, then what happens? If gt is greater than u sin theta, means smaller term minus larger term. That is, you will get smaller value minus larger value. That is, Vy becomes negative. So implies Vy becomes negative. Vy becomes negative in the sense that after reaching highest point, as time goes on further, what happens? Vertical velocity becomes negative means the direction of motion along the y-axis gets reversed. Means retracing. Gets reversed. So what is the reference here? As far as equation of motion along vertical direction is concerned, we have Vy equal to u sin theta minus gt. This is what equation representing negative sign for gt. So with this negative sign, we came to know that this is equal to body projected vertical upwards along y-axis, in which at some instant ta, that is u sin theta by g, vertical component becomes 0. So later on, what happens? As time further increases, gt gets more than u sin theta, that is then Vy becomes negative, means the direction of motion gets reversed after reaching highest point. Am I right? So what about horizontal motion here? Along horizontal motion there is no change in velocity. Why? Because there is no component for acceleration along horizontal, so speed becomes constant. So this is what uniform motion. Is what? Up to highest point, uniform retardation. Beyond highest point, uniform acceleration. Like that. Okay. Right? Because of this horizontal component, it covers some horizontal distance. Because of this vertical component, it gets elevated to some height. Right? So the combined effect leads to get parabolic path like see. It's a parabolic path. In fact, this is the velocity of projection, which makes an angle theta with the horizontal, otherwise x-axis. Right? Now, see here, path gets some horizontal distance because of what component? Horizontal component, and gets elevated to some height before vertical velocity becomes 0. Right? This is what plus h. Right? Plus h. Now here path will get some height because of vertical component of velocity. Right? Okay. Now let us see few more points here. What are the points here? Suppose as time goes on here, vertical component of velocity decreases. Vertical component of velocity decreases like that. See, as time goes on, vertical component of velocity decreases like that. This is what projectile, right? Path of the projectile, right? So it takes parabolic path because of combined effect of vertical component of velocity and horizontal component of velocity, right? Okay. Now, what is the velocity of projection here? U. The velocity of projection is U like that. This is what U. Okay. Now, what is the horizontal component here? Horizontal component, let it be Ux, right? What about vertical component here? That is what Uy. Uy in red and Ux in blue, right? Now this is what point of projection O. Okay, right? This highest point let it be A. And this is what point which lies on the same level as that of point of projection. See, O and B are on the same level, at the same level. See, B is the point which is at the same level as that of point of projection. Okay. Now I selected 3 points on the parabola. Point of projection O, highest point A, and point which is at the same level as that of point of projection. Now I am going to check instantaneous velocity at some points. That is, apart from instantaneous velocity, horizontal velocity and vertical velocity also going to check here. Suppose at point somewhere here P1, at this point P1, horizontal velocity. What is horizontal velocity? Uxo. Ux. What about vertical velocity? As time goes on, what about vertical velocity? Decreases or increases? Decreases as per this relation. So I will write on vector with smaller length and compared to previous vector. See, this is what some larger vector, but here it is some shorter one. Means the magnitude of vertical velocity decreases by reaching this position, right? Okay. Suppose I am taking one more point somewhere here, at which horizontal velocity again same only, that is U cos theta, Ux only. Is what? Ux. See, at all these 3 positions, the length of vector Ux remains same here, and there. Means the magnitude is not at all changing along horizontal. The magnitude of velocity not at all changing along horizontal, right? Of course, that direction also not changing. That's the reason why they are calling it as uniform motion. So horizontal motion is the uniform motion, right? Now what about vertical component here? Further decrease in length. Okay, so this is what point P2, right? Now this is what Vy. This is what Vy. Here also Vy, right? See, as time goes on, length of vertical component of velocity decreasing, means the magnitude gradually decreasing. At highest point, it becomes 0 also. It becomes 0 at highest point. So here, vertical component 0, right? What about horizontal component? We have same value. Same. See, horizontal component is expressed in blue, right? With same length everywhere. Means magnitude of horizontal component of velocity remains same, apart from direction. So this is what Ux, right? Now what about vertical component Vy 0 at highest point? Vy 0 becomes 0 at highest point, right? Now I am taking one more point at somewhere here. which is at same level as that of P2. See, this is what P2. Now this is what P4. This is what P5. Here P3. Here it is P3. Here it is P4. Right? Now at point P4, whatever horizontal component remains same length ux. Now coming to vertical component. See, beyond highest point, the direction has reversed. Up to highest point, vertical motion is upwards. Beyond highest point, vertical motion gets reversed, means downwards. Here onwards, downwards. Just beyond highest point A. So at every point, vertical component gets reversed, means I have to express along negative y direction. See, as these two are at same level, you have to draw the vector with same length as at P2. So this is what Vy. So P2 and P4 are at same level, therefore vertical component of speed, vertical component of velocity otherwise should have of same length. Direction only gets reversed. It is upwards, it is downwards. Right? Now coming to P5, somewhere here, P5, which is at same level as that of P1. Right? So P5, at point P5, what is the horizontal velocity? Remains same, that is ux. Now vertical component downwards with same length as at P1, right? Like that. See, these two are of same length. Okay. What is here? Vy. Now at point B means level of projection. These two are at same level. Right? Here point P6, otherwise B. At point B, what is the horizontal component of same length, that is ux? Right? Vertical component uy, that is Vy otherwise. Vy or uy, same length as that of at O line. See, these two are of same length. Okay. So that's how one can represent components of velocity at every point on the trajectory. Right? So up to O to A, vertical component is upwards. Especially at A, vertical component of velocity becomes 0. So beyond A, that is beyond highest point, again vertical component gets reversed, means downwards like that. Downwards, see, downwards. Horizontal component throughout the motion pointing along horizontal, that is pointing along positive x-axis. Ux horizontal. So Ux remains same both in magnitude as well as direction. So horizontal motion is uniform motion, but vertical motion is up to highest point, that is equivalent to body projected vertical upwards, means gets uniformly retarded beyond highest point until it reaches a point which is at same level as that of point of projection. Vertical motion is downwards, it gets uniformly accelerated, means freely falling. Behaves like freely falling. So along y-axis up to highest point, body behaves as it is projected vertical upwards, right? Beyond highest point, along vertical direction, particle behaves as it freely drop. So that's the reason why here projectile motion, especially oblique projectile motion, is the combination of two linear motions which are mutually perpendicular to each other. One is along x-axis, that is what uniform motion. Another one is along y-axis, that is what for half of the motion uniformly retarded, for rest of the motion uniformly accelerated, right? Okay. Here we have a projectile which is projected with some initial velocity u, such that making an angle theta with horizontal, whose components are ux and uy along horizontal and vertical respectively. After t time, we have components along x and y as follows. Vx equal to ux, u cos theta, no change at any instant. Vy equal to sin theta minus gt. So these are the equations for vertical and horizontal velocities after t time. Similarly, at the same time, what is the horizontal and vertical displacements covered by the projectile? Let us see. Let us see. Along horizontal, take s equal to ut plus of at square. Of at square. That is sx equal to uxt plus of axt square. That is sx equal to ux means what? Ux means u cos theta. U cos theta. That is u cos theta into t plus half into ax means what? 0. Along horizontal there is no acceleration. Along horizontal acceleration ax equal to 0. Along vertical that is ay equal to minus g as per sign convention into t square. So that is sx equal to u cos theta into t. That is ux into t. That is u cos theta into t. U cos theta means ux into t. So this is what displacement covered by projectile along horizontal after time t in time t. So sx equal to ux into t. So in the same way, vertical displacement covered after t seconds. Suppose let this is the position of the particle after t seconds. So by reaching this position, what is the horizontal displacement covered? This one. What is the vertical displacement covered? Let us see. Take equation along y-axis, that is s equal to again ut plus of a t square. That is sy equal to uyt plus of ayt square. So sy becomes equal to uy means what? U sin theta. U sin theta. So u sin theta t plus half into ay means what? Minus g into t square. So sy becomes equal to u sin theta t plus or minus of g t square. Right? So these are the horizontal and vertical displacements covered by projectile in time t after projection. Right? Okay. Of course here sx finds no negative sign here. U cos theta. U cos theta means horizontal velocity along horizontal at time t equal to, that is initial velocity along horizontal direction. U cos theta constant. Okay. So sx equal to x into t, that is u cos theta into t. As time goes on, sx increases. Sx increases. Am I right? So when it strikes the point B, which is at same level as that of point of projection, sx becomes maximum. Right? If t becomes maximum t, means t becomes maximum, that is t becomes time of flight, then sx becomes range, horizontal range. See, this is what total horizontal displacement covered in entire flight. So from here to there. So distance OB along horizontal becomes horizontal range in its entire flight. So if t becomes capital T, that is time of flight, sx becomes range, horizontal range. Right? Sy finds negative sign here. Right? As time goes on, what happens? This becomes increases. See, as time goes on, t square increases, object t square also increases and becomes equal to u sin theta into t at some instant. Then sy becomes 0 also. So sy equal to u sin theta t minus of gt square. Right? If of gt square equal to u sin theta into t. See, this second term has negative sign becomes equal to the positive term. Then half gt square becomes equal to u sin theta into t. Then sy becomes 0. Implies sy becomes 0. Right? Implies sy becomes 0. Now, what time sy becomes 0 means make it subject t here. So that is t gets cancelled. of g into t becomes equal to u sin theta. So t equal to u sin theta by 2 into u sin theta by g. In fact, this is what time of flight. Time of flight. Am I right? Capital T. Yes, point becomes capital. So in what time Sy becomes 0 means 2u sin theta by g. 2u sin theta by g. Why it is time of flight means in entire flight, time of flight, in entire flight, what is the vertical displacement covered means 0. Why? Because here see Sy becomes 0 in entire flight. So during ascent, what is the height through which it gets elevated means this is what vertical height like plus h, right? During ascent, what is the vertical height covered by the projectile here plus h during ascent, that is t becomes equal to ta, right? T becomes equal to ta. From O to A, it gets elevated through plus h, right? From A to B, it gets descended through h with negative sign. Why? Because during ascent, displacement is upwards. During descent, displacement is downwards, right? It is downwards line. It is downwards line. Minus h. This is what t, d. So t becomes td. From here to there, what is the time taken? Time of ascent. From here to there, time of descent. That is time to reach point which is same level as the point of projection from highest point is time of descent. From here to there. From A to B, time taken is td. From O to A, time taken is ta. So from O to A, what is the height gets elevated means plus h. From A to B, what is the displacement means minus h. Why? Because displacement downwards here. Here upwards. Now in entire flight, what is the total vertical displacement covered? Plus h minus h. So that is plus h minus h. 0. Sy becomes 0. In Sy, in entire flight, vertical displacement covered, right? So here in t equal to capital T, in a time t equal to capital T, in time t equal to capital T, that is time of flight, Sy becomes equal to plus h minus h, plus h plus of minus h, that is 0, that is 0, right? So here what is the time here? T becomes capital T. From O to A, what is the time here? T becomes Ta. From A to B, what is the time here? T becomes Td, right? T becomes Td, like that. Okay. Now let us see. Here, these are the equations which governs entire projectile motion here. That is equation of motion along x-axis, equation of motion along y-axis in case of velocities. So in case of displacements, equation, this is also one of the equations of motion, that is s equal to ut plus half h square along x, along y. Here velocity along x, along y. So these are the equations according to which one can understand the entire motion of projectile, right? Now let us see few more points in the same case. Few more points in the same case. See here, this is what path of projectile, like that. Okay, so I am taking 3 points on the trajectory O, A, B, like that. O, A, B, O, A, B, right? At highest point, what about vertical velocity? 0. We left with only horizontal velocity, that is Vx becomes equal to Ux, right? Here what is the velocity? Here velocity of projection at O, U. Here horizontal velocity Ux, the vertical velocity Uy, like that, right? Here what is the direction of acceleration due to gravity here? At O, G acts vertically downwards, right? Here also G acts vertically downwards, right? Suppose if I take one point somewhere here on the trajectory, here it is V for example. Here it is divided into two components, Vx that equal to ux. Why? Because horizontal velocity remains same, vx becomes equal to ux, the vertical velocity vy, right? Vertical velocity vy. Okay. Now here also particle is subjected to gravity, so accordingly it has acceleration due to gravity vertically downwards, right? Suppose here, if I take one more point somewhere here, is what vx, that also equal to ux. Here it is vy, right? Now what about acceleration due to gravity vertically downwards, right? So here velocity and acceleration due to gravity are directed opposite each other up to highest point. Means up to highest point vertical motion is retarded motion uniformly. But beyond highest point, acceleration due to gravity and vertical component of velocity pointing downwards. See, both are in the same direction. That means to say that beyond highest point, vertical motion is uniformly accelerated. That is freely falling. Up to here, vertical motion is retarded motion, uniform retarded motion. Beyond A up to B, vertical motion is uniformly accelerated motion, right? Okay. As time passes on, suppose here what is the angular projection theta? Here what is the angular projection? For example, here at this point theta 1. Here what is the angle made by net velocity with horizontal means 0. Why? Because here we have left with only horizontal velocity, which is pointing horizontal. So with respect to horizontal, what is the angle made by the net velocity means 0, 1. But especially at this point, angle between acceleration due to gravity and velocity, net velocity, that is 90 degrees. 90 degrees. Okay, right? See, from O to A, angle made by net velocity with horizontal gradually decreases. See, the theta is greater than theta 1, which is greater than 90. So from O to A means during ascent, theta is greater than theta 1 is greater than 90 degrees, right? Here it is 90. Suppose here it is theta 2, for example, that is 90. Okay, right? At each point, acceleration due to gravity acting vertically downwards. Now at highest point, what is the vertical velocity at A? At A means at highest point, Vy equal to. Now what about Vx? Vx equal to Ux. That is U cos theta. Right? At this position also, horizontal component velocity becomes equal to U cos theta, which is equal to initial velocity at O along horizontal. That is Vx equal to Ux, that is U cos theta. Right? Now what is the angle between G and velocity at highest point? See next point. Angle between velocity and acceleration due to gravity at A. A means highest point. What is the angle between net velocity and acceleration due to gravity at highest point? 90 degrees. So theta that equal to 90 degrees. So projectile moves horizontally at highest point. Why? Because it finds only horizontal component. We left with horizontal component only at highest point. It doesn't have any vertical component. Why? Because that is 0. That is 0 at highest point. Right? So projectile moves, especially oblique projectile. Projectile in the sense oblique projectile. So oblique projectile moves horizontally at A. Oblique projectile moves horizontally at A. A in the sense, in my view, that is highest point. Right? Highest point. But here see, if you observe, the direction of motion continuously changes from time to time. See here, this is what. How can you assign the direction of motion? Means The direction of motion is usually taken in the direction of instantaneous velocity. Instantaneous velocity means net velocity. See, this is what net velocity at point of projection, u. Here, v is the net velocity or instantaneous velocity. Here, horizontal component itself, net velocity or instantaneous velocity. Why? Because vertical component is 0. Here, this is the net velocity. This is the net velocity, right? So, net velocity means instantaneous velocity, that is always tangential to the at a given point on the trajectory. So, here, see, this is the direction of motion. Here, this is the direction of motion. Here, this is the direction of motion. Here, this is the direction of motion. Like so, from instant to instant, the direction of motion of projectile changes, right, and becomes horizontal at highest point in case of oblique projectile, right, like that. Okay. Now let us see one numerical based on all these points. Based on all these points, let's see one numerical. Suppose a body is projected with some initial velocity 50 meters per second in a direction making an angle 53 with the horizon. Now in that case, express initial velocity vector, right, at point O, similarly velocity at point A and velocity at point B, right? See, this is the given question like that. Your velocity of projection u equal to 50 meters per second, which makes an angle theta, that is 53 degrees with the horizon. Now here you are given 3 points on the trajectory. O, point of projection, A, highest point, B, the point at which it lands on the ground, which is at the same level as that of point of projection, right? Now the question is, number 1, find u bar at O. At O, find the initial velocity in vector form at O, right? Velocity at A in vector form and velocity at B in vector form. Number 2, find direction of motion, and net velocity after 2 seconds. Find direction of motion and net velocity after 2 seconds. Right. Number 3, find displacement. After 2 seconds from the projection, right? Now let us see first point. Number 1, initial velocity u0. See, here u can be resolved into 2 components. See, this one u bar, in fact that is, it is theta, it is y-axis, right? Here it is ux. If I close this side, this one y-axis. Now here, what is the component along y-axis? Uy, right? So ux means u cos theta, uy means uy. These two sides are same, that is uy equal to u sin theta, right? So ux equal to u cos theta, that is u means what? 50. The cos theta means cos 53. Cos 53. What is the value of cos 53? We have one basic right angle triangle. It is 53 cos 53 means 3 by 5, sin 53 means 4 by 5. So cos 53, 3 by 5, that is 50 into 3 by 5. So 5 times 10 to that is 30 net per second. Similarly, Vy. What is Vy? That is Vy equal to u sin theta. U sin theta. That is u means 50. Sin theta means 53. That is 50 into sin 53 means 4 by 5. 4 by 5. Right? That is 40 meter per second. So we have horizontal as well as vertical initial components of velocity. Now, how to express in vector form u bar equal to u bar at O, velocity, initial velocity vector, that is velocity projection at O, can be written as, see, this is what ux, this is what uy. So ux into I cap plus uy into j cap, that is ux I cap plus uy j. That is ux means u cos theta into I cap plus uy means u sin theta into j. That is equal to u cos theta. Ux means u cos theta. That is what 30. So 30 into I cap plus u sin theta means 40. 40 into j cap. This is what velocity projection at O in vector form. In vector form. So number 1 is over. So velocity at A. Velocity at A. Number 2. Velocity at A means at point A, we left with the horizontal component, that is Vx becomes equal to Ux. Same as at the point of projection. Why? Because horizontal velocity remains same at any point on the trajectory. Why? Because along horizontal there is no acceleration. Right? So V is what V x at A equal to ux at A plus ax into t. So V equal to u plus at, take along horizontal, take x component, V x A, that is Vx A plus ax at A into tan. That is ux at A, u plus a, that is Vx means 2 cos theta plus ax means 0 into t, because there is no acceleration along origin. That is Vx at A equal to u cos theta. U cos theta, that equal to u cos theta means what is u cos theta? U cos theta already found 30 meter per second. 30 meter per second, right? Now what about the vertical component of velocity at A? Vy at A equal to uy plus ay into t. Right? Vertical component. Here vertical velocity becomes 0 at time of ascent. That is uy means what? U sin theta. Ay means minus g. T means ta. Time of ascent. Ta. So from here to there, what is the time taken? Ta. Time of ascent. What is the expression for time of ascent? U sin theta by g. Already we found previous session. That is u sin theta plus or minus g into time of ascent. U sin theta by g. U sin theta by g. UG cancel. U sin theta minus U sin theta, that is g. So vertical component of velocity at highest point is 0. So in vector notation, V bar at highest point A equal to Vx into I cap plus Vy into j cap. That is Vx. Vx means what at A? 30 meter per second. I cap plus Vy means 0 into j cap. That is V at A equal to 30 I cap. In fact 30 means u cos theta. That is u cos theta into I. u cos theta into I cap, right? Now at B, what is the value here at B? At B means I'm rubbing off somewhere here, writing somewhere here. V at B, number that is V at B. See here at point B, this word Vx, this word Vy, right? So Vx remains same, that is Vx. Vy, this word Vy equal to Uy, that is U sin theta. Uy, that is U sin theta. U sin. So in vector notation, at point B, Vb bar equal to horizontal component, that is U cos theta. U cos theta into I cap plus vertical component Uy. That is what Uy means, U sin theta. So U sin theta into minus j. Why? Because this is downwards, acting downwards. So this horizontal I cap, vertically downwards, minus j cap. So U cos theta into I plus U sin theta into minus. That is U cos theta means what? Already you have U cos theta, that is 30 I plus U sin theta means what? 40 minus. So 30 I plus or minus 40 right? Okay. Now find direction of motion and net velocity after 2 seconds. Find direction of motion and net velocity after 2 seconds. Direction of motion after find the direction of motion and net velocity after 2 seconds. After 2 seconds, what is net velocity means we have to consider velocity along horizontal as well as along vertical after 2 seconds, right? So question number 2. Net velocity after 2 seconds. Suppose see this is the path followed like that. After t seconds, particle remains somewhere here. Thus that its velocity is acting tangential here. The velocity can be resolved into 2 components. One is Vx, another one is Vy, for example. Right? Now take horizontal velocity. V equal to U plus At. That is Vx, Ex, Ax. Now Vx equal to Vx means U cos theta. Thus Ax means 0. Along horizontal, what is the acceleration of 0? Along vertical, Ay, that is minus g, right? As usual, minus g, right? So into t, that is U cos theta. Vx means again U cos theta. U cos theta already found. U 50 cos theta. Theta means what here? What is theta here? 53, right? So cos 53, that is 50 into cos 53, 3 by 5, that is same 30 meters per second. Now what is the vertical velocity here? V equal to U plus At. Take along y-axis, same expression. Vy equal Uy plus Ayt. So Uy means, what is Uy? U sin theta plus minus g into t. A means minus, that is U means 50 sin theta. Sin 53 means 4 by 5 plus or minus g means take 10 for example into t. T means what here? After 2 seconds, 2, that is 50 by 5, 10 4 ja 40 minus 20, that is 20 meters per second. So Vy becomes equal to 20 meters per second. not equal to 0 means not at reached highest point. So this is what highest point. In fact, Vy still has some value, that is 20 meters per second. If it is 0, it reaches highest point. So it is not, as it is non-zero for Vy, as it is non-zero, particle still not at reached highest point. So it lies somewhere between O and A, somewhere here, right? So we have Vx, Vy. Now what is the net velocity? Net velocity means here V equal to Vx into I plus Vy into J. That is net velocity. V bar equal to Vx. Vx means 30. 30I plus Vy means 20. As it is positive sign, take positive. That is 20J. 20. How to find direction of motion? Suppose here net velocity or instantaneous velocity making some angle alpha with the horizontal. Some angle alpha with the horizontal. Now take tan alpha and make it subject alpha. That's what direction. That's above the horizontal. So tan alpha equal to tan alpha. See here. This is what Vx. This is what Vy. Join somewhere here. Vy. Hypotenuse. What is hypotenuse here? V. So here it is alpha. So tan alpha Vy by Vx. Vy by Vx. Tan alpha Vy by Vx. So what is Vy? Vy means 20. Vx means 30. So 20 by 30. That is 2 by 3. So alpha equal to tan inverse 2 by 3. So this is the direction of motion above the horizontal. Right? Above the horizontal. Alpha equal tan inverse 2 by 3. Right? Now at the same instant, what is the angle between acceleration due to gravity and instantaneous velocity? Suppose here, this is what velocity. It is velocity V. Right? Now at this point, what is the direction of acceleration due to gravity? Vertically downwards. G. Right? Now this is what horizontal. Now what is the angle here? 90 degrees. Here alpha. See, this is what alpha. Okay. Here it is alpha. What is the angle here? Alpha. Here 90. Now what is the angle between these two vectors? 90 plus alpha. So angle between V bar and G bar at point P. At point P. See, this is what point P. Equal to 90 plus alpha. 90 plus alpha, right? See, this is what G. Here it is G. G acting downwards. So here angle is 90 degrees. 90 plus alpha is the angle between V bar and G bar. So 90 plus alpha, that is equal to 90 plus alpha means what? Tan inverse 2 by 3. Tan inverse 2 by 3. Okay. So that's how you can find direction of motion. So if you want to get direction of motion, how to get? Take alpha equal to tan inverse of vertical velocity by horizontal velocity. See here, alpha equal to tan inverse of vertical velocity by horizontal velocity at that instant. That gives the direction, means angle made by instantaneous velocity with the horizontal. Okay. Now, so find the direction motion over and net velocity after 2 seconds also over. Now find displacement after 2 seconds. Displacement this time. See here, in the same way as it is a 2-dimensional motion, you have to find velocity along horizontal as well as vertical to find net velocity. In the same way, if you want to get net displacement, we have to find displacement along horizontal as well as vertical at that given instant, right? Okay. So we have to proceed in the same way. Right? displacement number 3. Find displacement after 2 seconds. See, this is the path followed by the projectile. This is the path. Suppose this is the position of the particle after t equal 2 seconds. Now if I close this side, this is what vertical displacement Sy. Now this is what horizontal displacement Sx. Right? Now this is what net displacement. A line segment drawn from initial position to given position. This is what displacement, right? Net displacement. This is what Sx, Sy, S. Okay. See, I am highlighting somewhere here. Sx, Sy, S. Net displacement. Otherwise, position vector. This is also known as position vector, right? R bar or S bar. R bar or S bar. Position vector or displacement vector. Both one and the same in this case. So R bar or S bar. This is what? The line segment drawn from initial position O to given position after t equal 2 seconds. This is what P. Position P. Right? Now, angle made by displacement vector with the horizontal is known as angle of elevation pi, which is other than angle of projection, right? Direction of motion. This direction of motion we have to take tan alpha, that is vertical component of velocity by horizontal component of velocity. But here it is not direction of motion. This is what angle of elevation. Angle of elevation pi equal to Sy by Sx. See, this is what pi, that is Sy by Sx. Opposite side by adjacent side, tan pi equal, right? Now take equation along x. S equal to ut plus half at square along x axis. That is ux means u cos theta into t plus half into ax means 0 into t square. Now u cos theta, u means 50, cos theta means what? 53. Cos 53 degrees into t. T means what? 2 seconds. That is 2 into 50, 100. So cos 53 means 3 by 5. 3 by 5. 100 by 5. That is 20. 20 into 3 means 60. Net per second. Sorry, meters. 60 meters. Sx. Similarly, Sy vertical displacement Sy equal to S equal to ut plus half at square. Take y like that. Sy equal to uyt plus half ayt square. That is Sy equal to uy u sin theta into t plus half into ay means minus g into t square. U means what? 50 meters per second. Sin theta means sin 53, that is 4 by 5. 4 by 5. 4 into time, t means 2 seconds. Plus half minus half into g means 10. T square means 2 square. That is what? 10 into 4, 40 into 2, 80 minus 2 square means 4, 4 by 2, 2 into 10, 20. Again 60, that is 60 meter. Sy also 60 meters. So, after time t, or in time t is equal to 2 seconds, horizontal displacement covered is 60 meter, vertical displacement covered also 60 meter. Right? In vector notation, how to write in vector notation, that is S bar equal to Sx into I cap plus Sy into j cap. That is S bar equal to 60 I cap plus 60 j cap. Right? Both are positive. Sx comes with positive sign, here Sy also comes with positive sign. That is 68 plus 60. Now, what is the angle of elevation? Tan pi. Tan pi equal to Sy by Sx. See here, tan pi equal to Sy by Sx. That is pi equal to tan inverse of Sy by Sx. Sx, that is phi equal to tan inverse of 60 by 60 means 1. Tan inverse 1. 1 means that is 45 degrees. Phi equal to 45 degrees. 45 degrees, right? Okay. Now let us see in the same way, let us see momentum at O, at A, at B. Momentum. As velocity changes from instant to instant in case of projectile, momentum also changes. What is momentum? Product of mass and velocity. Product of mass and velocity is known as momentum, right? Suppose find momentum at O, at A, and at B, right? Moment at O means number 1, momentum at O, PO bar equal to M into V at O bar, right? So here mass is not given, take the symbol, that's all. That is M into velocity at O means U cos theta into I plus U sin theta, that is U cos theta into I plus U sin theta into J. That's velocity at O means Ux into I cap plus Uy into J cap. That is U cos theta into I plus U sin theta into J. Right? That is already we found here M into U cos theta is 30I. Here 30I. We calculated in previous session, that is 38 plus U sin theta 40 J. 40. That's what momentum at the O. Momentum at the A. Momentum at the A. That is M into velocity at A. That is M into velocity at A. Already we calculated. We left with horizontal velocity at highest point. That is U cos theta. U cos theta into I. Right? At highest point we have only horizontal component. Why? Because vertical component is 0. So horizontal component itself, net velocity or instantaneous velocity. So M into U cos theta into I. That is M into, what is U cos theta here? U cos theta means 30. We calculated. That is 50 into cos 53. That is 50 into 3 by 5. 30. Right? That is 30 into I cap, like that. If you want to get the change in momentum during ascent, that is delta P bar, change in momentum from O to A, that is P at A bar minus P at O bar, that's all. Change in momentum. Here at point O, momentum so and so, at point A, momentum so and so, both differ in magnitude as well as direction. Obviously we have some change in momentum, linear momentum, before reaching highest point from point of projection. What is the change here? Final momentum vector minus initial momentum vector. That is PA bar minus PO bar. PA bar means, what is PA bar? This is M into 30I minus PO. PO means this is what PO. That is M into 30I plus 40J. Right? Okay. So here M into 30A cancel. We left with the minus of this one, that is minus 40J. That is equal to minus M into 40J. M into 40J. That is minus M into 40J means what? 40J means U sin theta, Uy. That is U sin theta. Yeah? 40J means U sin theta. M into minus MU sin theta, right? Now coming to momentum at B. Momentum at B. Here velocity at B is like that. Bx horizontal, Vy vertically downwards, right? So momentum at B, PB bar equal to m into PB bar, right? M into PB bar. That is m into velocity at B means Vx into I plus Vy into minus J. That is Vx into I means u cos theta into I plus here Vy means Uy. That is u sin theta into minus J. Right? So this is what momentum, mass into velocity vector, right? B. So u cos theta into I plus u sin theta into minus J. That is what m u cos theta I cap plus or minus mu sin theta into j cap. Now, what is the change in momentum in entire flight? Entire flight means from O to B, like that. So delta P bar from O to B in entire flight from O to B, right? So what is the change in momentum in entire flight means final momentum vector here minus initial momentum vector, that is PB bar minus P at B bar minus P at O bar. That is P at B means this is what P at B, mu cos theta I, mu cos theta I plus minus mu sin theta J, right? PB bar mu cos theta I minus mu sin theta J minus PO bar. What is PO bar? This is what PO bar, that is M30I plus 40, right? M30I plus 40. Of course, you can write in values also, that is m into u cos theta means 30 I minus m into u sin theta means 40 J, like 40 J. So you can write in values otherwise. You can write in values. Okay. Now delta P bar equal to PB means this is PB. M30I minus m into 40J whole minus PO. PO means what? M into 30I plus 40J. M into 30I plus 40J. Like 40J. Okay. Now m into 30I minus m into 30I cancel. We left with minus m into 40J minus or plus minus m into 40J. That is delta P bar equal to minus 2 into m into 40J. See, these two same terms with the same sign. This is what minus. Second term also m into 40J also comes with the negative sign. Here also same with the negative sign. So twice minus 2 into m into 40J. Right? So that is what delta P bar equal to minus 2 into m into what is 40J? 40J means u sin theta. U sin theta into J. So this is what from entire flight. That is O to P, right? Okay friends, this concluding. Have a nice day. Thank you.